Hello my dear students, welcome back to my channel. ଏହି ଭିଡିଓରେ ଆମେ previous year question bank ରୁ electrostatic chapter ର 3 mark question discussion କରିବା. Let's start. State Gauss theorem and apply it to find electric field intensity due to infinitely long straight uniformly charged wire. Gauss theorem କଣ ବିଲେ? The total flux of electric field intensity E through any closed surface is equal to 1 by epsilon 0 times the total charge enclosed by the surface. ଏବେ ଆମେ ୟୁନିଫର୍ମଲି ଚାର୍ଜର ୱାୟର ଯୋଗୁ କେତେ ଇଲେକ୍ଟ୍ରିକ ଫିଲ୍ଡ ଇଣ୍ଟେନ୍ସିଟି ପ୍ରଡ୍ୟୁସ ହଉଛି ଡିସ୍କସନ କରିବା. ତ ଫାର୍ଷ୍ଟରେ ଆମେ ଡ୍ରଇଂ ବନେଇଦବା. ଲେଟ୍ ଦିସ୍ ଇଜ ଏ infinitely long charged wire ଯୋଉଥିରେ କି only positive charge ଅଛି. ଯେହେତୁ ଏଥିରେ positive charge ଅଛି, electric field direction is radially outward. To find the electric field intensity, first draw Gaussian surface and এইଠି Gaussian surface cylindrical surface ହବ. ତ first draw a Gaussian surface. ତ ଏଇ ଯୋଉ cylindrical Gaussian surface ରେ କେତେଟା surface ଅଛି ପିଲେ? 1, 2, 3. ଗୋଟେ curved surface and this one is your flat surface and this is also your flat surface. ତାହେଲେ surface element ଏଇ one surface ରେ direction ହବ upward. Surface 3 ରେ surface element ହବ downward and the curved surface ରେ radially outward. ତ E ର direction and dx ର direction surface 2 ରେ same ଅଛି. But 1 and 2 ରେ direction କଣ ଅଛି ପିଲେ? 90 degree. ଏବେ ଆମେ flux first total flux through whole Gaussian surface କେତେ ହେଲା find କରିବା. ତାହେଲେ total flux phi E is equal to phi 1 plus phi 2 plus phi 3. Flux ର formula କଣ ପିଲେ? Integration of E dot ds. First surface ରେ E and dx ଭିତରେ angle କେତେ ପିଲେ? 90 degree. ତ E ds cos 90 degree plus surface 2 रे angle between E and ds is 0 degree. So integration E ds cos 0 plus surface 3 रे angle between E and ds is 90 degree. So angle integration E ds cos 90. Cos 90 equal to 0. So this term becomes 0. This term also becomes 0. E integration of ds and here cos 0 is equal to 1 is equal to E into cylindrical surface surface area kete, that is equal to your 2 pi r l. Now apply Gauss theorem, that is equal to phi E is equal to q by epsilon 0. It implies E into 2 pi rl is equal to q by epsilon 0. Let lambda is the surface linear charge density which is equal to q divided by L, which implies q is equal to lambda L. Put here lambda L is equal to epsilon 0. LL cancel out. E becomes q divided by 2 pi r epsilon 0. Next, charges 1 microcoulomb, 3 microcoulomb and 5 microcoulomb are placed at corners of an equilateral triangle with side 10 to the root 3 centimeter. Calculate electric static potential at the center of the triangle. First draw a equilateral triangle. P is the center of the equilateral triangle where we find the electric potential. D is the midpoint of BC so that BD equal to 5 root 3. Now in triangle BPD, angle D is 90 degree. Angle BDP is equal to 90 degree. So this is a right angle triangle. The total angle B is 60 degree. Angle PBD is equal to 30 degree. Angle in right angle triangle BPD, in triangle BPD, cos 30 is equal to BD by BP, which implies BP equal to BD by cos 30. BD equal to 5 root 3. Cos 30 is equal to root 3 by 2. Root 3 cancel out. Then it becomes 10 centimeter, which is equal to 10 to the power minus 1 meter. Now, at point P, what is the potential? V P. Vp is equal to Va plus Vb plus V equal to K. A point रे charge केते अछि पिले -5 into 10 to the power 6 coulomb divided by what is R AP. ए जो distance AP रहला AP केते पिले Vp जहा AP तहा and Cp भी तहा तो 10 to the power -1 plus what is Vb K into charge, that is 1 into 10 to the power -6 divided by 10 to the power -1 plus K. What is charge at C? That is equal to 3 into 10 to the power -6 divided by 10 to the power -1, which is equal to K divided by 10 to the power -1 को common नहीं जीवा, 10 to the power 6 को also common नहीं जीवा, ताले -5 plus 1 plus 3 equal to K into 10 to the power -6 into -1 divided by 10 to the power -1. So finally it is K into 10 to the power -6 plus 1 is equal to -K 10 to the power -5. K ର value କେତେ ବିଲେ 9 into 10 to the power 9 into 10 to the power -5 is equal to 9 into 10 to the power 4 volt. Next, derive Coulomb's law from Gauss law in electrostatics. Let Q is a charge. Let's draw a Gaussian surface of radius, Gaussian spherical surface of radius r, and Q that is placed at the center of the sphere. Now this is a positive charge, so electric field direction is radially outward and also the surface element is radially outward. So angle between E and ds is equal to 0 degree. Now apply the Gauss law. What is Gauss law? Phi E, total charge, total flux enclosed by a surface is equal to 1 by epsilon 0 times the total charge enclosed by the surface. E and ds भीतर angle कितने है बेले 0 degree. तो E ds cos 0 is equal to Q by epsilon 0. E integration ds, because cos 0 is equal to 1, is equal to Q by epsilon 0. Now the surface area of a sphere is equal to 4 pi r square. So E into 4 pi r square is equal to Q by epsilon 0. So E equal to 1 by 4 pi epsilon 0 Q divided by r square. इति बचाची Coulomb's law, and Coulomb's law simply deals with the force. ताहले electric field and force with relation कौन बिले? F is equal to Q0 into E is equal to 1 by 4 by epsilon 0 Q0 divided by r square. तो ये है तुम्हारा Coulomb's law. हमें derive कर ले Gauss law. Next, an electric charge Q is uniformly distributed around a semicircle of radius A. Calculate electric potential at the center of this semicircle. Let's draw a semicircle of radius. Let's O is the center, A is the radius of the semicircle, and Q is uniformly distributed over the semicircle, means total charge over the semicircle equal to Q. Now at the center of the semicircle, what is the potential? Potential at point O is equal to, let P is a point where charge is equal to small dq, and the distance from O to P is equal to, let equal to the radius A. So at point O, potential VO is equal to K integration dq divided by the distance A. A is constant, so it can be written as K by A integration of dq. The total charge around a semicircle is equal to capital Q. It means integration of dq is equal to Q, which equal to K A Q. Thank you.